Automatic Addison.
Welcome back, everyone. In this tutorial, we are going to build basic programs using Python. Let's start by building a basic calculator. This exercise will help you understand how to handle user input and perform basic arithmetic operations in Python. So let's start, as we always do, by opening a terminal window. And let's move to the directory where we will store our code. cd space ~documents/Python tutorial. Enter. Okay, so now we are in our directory. And I am going to be using VS Code in this tutorial, but you are free to use your own code editor. So to open VS Code, you type code, space, and then the period. Let's open that up. All right, and let's clear. X out the welcome screen. Now let's create our new file. Go over to the Explorer pane and right-click and click New File. Type basic_calculator.py and press Enter. And so first, let's ask the user to input two numbers. Type the following lines. num1 equals float, open parentheses, input, and let's do open parentheses again, and let's do single quotes, and let's say enter first number, colon, space. On the next line, we do num2 equals float, open parentheses, input, open parentheses, single quote, enter second number, space, save. These commands prompt the user for input, converting the input into floating point numbers for arithmetic operations. Next, we need to ask the user to choose the operation. Do we want the user to add numbers, subtract numbers, multiply, or divide? So let's create a variable for those options. We are going to type here operation equals input, open parentheses, choose the operation, space, add, subtract, multiply, divide. Add a colon there. Let's make sure this is single quote, so we are following the ROS2 Python style guide. Since we need no escaping, I'll teach you what escaping is later in a future tutorial. We can use single quotes here. It's actually the preferred way. Let's save. Everything looks good. No errors. Okay. Now we'll use conditional statements to perform the operation selected by the user. So we need if statements to do this. If operation equals single quote addition, colon, result num1 plus num2. elif operation equals single quote subtraction, colon at the end there, result, and then num1 minus num2. Num stands for number, in case you're wondering. Now, let's go to the third operation option. elif operation equals multiplication, do colon, result equals num1 times num2. Next line. And finally, division. elif operation equals division, colon, if num2 not equal to 0, because we are not able to divide by 0. We can't divide by 0, so we need to do a check before we do the division. Result equals num1 divided by num2. Else result equal invalid. Let's do single quote there. Invalid operation selected. Save. All looking good. Single quotes. ROS2 Python style guide will be all happy. And finally, let's do an else statement at the end here. So else. So if operation is addition, subtraction, multiplication, division, and if we'll do here result equals invalid operation selected. So if the user enters an invalid operation, we need to have a way to handle that use case. Now down here, let's do print, open parentheses, result. Okay, now let's run it. Let's run our calculator, see if there's any issues. Into the first number, let's type the number 4. Into the second number, let's type 6. Let's add the numbers. So we'll do the plus sign. And you can see 4 plus 6 equals 10. Now let's clear. All right, and let's do another one. Let's run it again. Click run. Let's do 6, 4, and let's do division. 1.5. So 6 divided by 4 is 1.5. So you look at the code and look what's going on here. This if-else structure, if-elif, helps our calculator to decide what to do based on the user's choice. Pretty cool, huh? So when you enter the numbers, you're prompted for the numbers as well as the operation you want when you run the program. And you can watch the program calculate and display the result. Now let's see how to make our program basiccalculator.py executable. We will do this directly from the command line. This will enhance your workflow by allowing you to run your Python scripts without explicitly calling the Python interpreter each time. Let's begin by going to the top of this program, basiccalculator.py. And at the very top of the file, we need to add what is called the shebang line, shebang, the shebang line. You'll see this in many Python programs. And we need to write this right here. Pound, exclamation point, /USR, /bin, /env, space, Python 3, and then save. This is the shebang line right here. Pound, there are the hash symbol. There you go at the exclamation point, /, use USR, /bin, /env, V is in victory, and then space, and then Python 3. This shebang line tells the system that this script should be run using Python 3, which we've installed on our machine. So make sure this line is at the top before any other code. So now we will save the file. You do Control S or go to the upper left and type File, Save. All right. And now we have a terminal below here. I'm going to clear that out. And now let's make the program executable by doing this command, chmod, change mode, space +x right there, and then basiccalculator.py. Now do enter. Now you can run your Python script directly from the command line. So how do you do that? To run your script, you simply type period, / and then the name of the program, basiccalculator.py. And here we enter our first number. Let's enter the number 9. Now let's enter the number 8. And let's do multiplication this time. 72. 9 times 8 equals 72. So there it is. That's how you made your program executable. Notice how you didn't have to type Python 3 before the script name this time. The system recognizes this program as an executable file and runs it using the Python interpreter specified in the shebang line. So go ahead and test different inputs now to see how your calculator works now as an executable script. Let's explore how to perform basic calculations in Python. We'll cover addition, subtraction, multiplication, division, and a bit about modulus operations. Let's get started by opening your code editor. I already got it open here. I'm going to X out of that. Let's clear here. And let's create a new file called basiccalculations.py. All right. In this file, we'll write small code snippets to demonstrate each type of calculation. Let's start with addition. So I'm going to do a comment here, pound addition. And let's do print, open parentheses, single quote, addition of 5 plus 3 is colon, and then after the single quote, put a comma here, and then do 5 plus 3 for the actual operation. Save. Press play. So addition of 5 plus 3 is 8. Okay, now let's do subtraction. Subtraction. Print. Subtraction of 5 minus 3 is colon. And let's do comma, and then the operation 5 minus 3. Let's check the result. Press the play button, and 5 minus 3 is 2. Now let's do multiplication. Multiplication. Print. Single quote. Multiplication of 5 times 3 is colon 5 times 3. Save it and press play. 5 times 3 is 15. Let's clear this terminal out so we can create some space here. And finally, division. Division. Print, open parentheses. Division of 5 divided by 3 is colon, comma, 5 over 3. Save. And run it right now, and we can see 5 divided by 3 is 1.6 repeating, which is correct. And finally, let's look at the modulus operation. The modulus operation gives the remainder of a division. So I am going to go down here, and let's do modulus. Print, open parentheses, modulus of 5, and then the percent symbol for modulus. 3 is, and let's do comma, 5 modulus 3. And before we run it, what do you think we should get? So 5 divided by 3, and what is the remainder when we do 5 divided by 3? Or we should get 2, right? 3 goes into 5 one time with the remainder of 2. So let's see if we get that. Press play. And in fact, modulus of 5, 3 is 2. So these operations that you just saw are fundamental to programming and form the basis for more complex algorithms and operations. Let's learn how to work with random values in Python. This capability is essential for simulating uncertainty in robotics applications and for creating varied testing scenarios. Let's clear this out and we will create a new file called working underscore with random.py. Enter. Working with random.py. And to generate random numbers, Python provides a module or library named random. First, we need to import this module. Import random. Let's begin with generating a random integer. We'll use the randint function, which returns an integer between the specified range. So I'm going to write a comment here. Generate a random integer between 1 and 10. Random underscore integer equals random dot randint, open parentheses, 1 comma 10. Now print random integer between 1 and 10, colon, comma, random underscore, just press enter there for the autocomplete, save, and let's run it, see what we get. So random integer between 1 and 10, we get 2. Let's run it again, get 3. Run it again, we get 9. So you can keep running it over and over, and you can see here that we get random integers between 1 and 10. So next, let's generate a random floating point value. The random function returns a floating point number between 0.0 and 1.0. So we will go up here and let's do generate a random float. Let's do random underscore float equals random dot random. Parentheses right there. Let's print out the result. We'll do random float between 0.0 and 1.0 colon. And we'll do comma random float. Okay, and let's press the play button, and you can see we have a random float between 0, 1, 0.697. Let's do it again. Another random float. Do it again. Another random number. Pretty cool. Now, sometimes you may want to generate a float within a different range. You can do this by multiplying the result of random. So let's do that right here. Generate a random float between 0.0 and 5.0. And let's do random float in range for the name of the variable equals random dot random. And let's multiply by 5 to get a random float between 0 and 1. And let's do print random float between 0.0 and 5.0. And we'll do comma, random float in range. Save it and press play. So you can see here we get 4.8. Get random numbers between 0 and 5. Clear. Now, how do we pick a random element from a list? Let's create a list of colors and select one randomly. So down here, I'm going to say pick a random element from a list. We're going to type colors equals, open bracket there, red, white, put that in quotes, blue. Do another one, yellow. Okay. Let's do red, white, and blue. Colors of the United States flag. Be patriotic today. Okay. Random underscore color equals random dot choice and then colors. So the choice operation right there, choice, and then the colors, the list name. And let's do the print operation to display to the terminal. Random color selected, colon, and then comma, random color. Enter. Save. And let's press play. Red, white, white, blue. So we get random selections from the list. Red, white, or blue. So that's how you use the choice operation to select a random element from a list. Lastly, if you want to shuffle the items in a list randomly, you can use the shuffle method. And let's do that now. We'll do random.shuffle, and we'll do open parentheses and colors. Save. And let's print out the result. Print shuffled colors, comma, colors. Save. Press the play button. You can see that at the bottom here? See that? Shuffles it like a deck of cards. Keep doing it. Keep pressing play. It'll just shuffle those values around. And you'll see the outputs for each of the random operations we scripted. So this functionality we showed you here with random is invaluable for creating diverse and dynamic environments in robotic simulations and tests. Okay, let's clear our terminal window. And let's explore how to work with NaN, not a number, and infinity in Python. These are special floating point values that you may encounter in numerical computations, especially when dealing with undefined or unbounded values. Let's start by going over here and opening a new file, and we will do NaN underscore and underscore infinity.py. Okay, NaN underscore and underscore infinity.py. It's the name of the program. So to use NaN and Infinity, Python doesn't require any special imports as they are part of the standard float type. Let's start with infinity. We'll do hash there for the comment, positive infinity. We'll do positive underscore infinity equals float. And then we'll do INF, save. And we'll do print, open parentheses, positive infinity. Let's do a colon there. And then comma, and then positive infinity, the variable. And while we're at it, let's also do negative infinity. And then negative underscore infinity equals float, open parentheses, and then do single quote minus INF, save. Okay, and we'll print, open parentheses, negative infinity, negative infinity. All right. And save. So these lines create variables for positive and negative infinity. Operations with these values yield predictable results following rules of mathematical infinity. Let's press play. Infinity and minus infinity. Next, we have NaN, not a number. It's a special value used to denote that a result of a computation cannot be defined in meaningful terms. So we will do the hash and do NaN example, not a number, equal float, and then NaN. Save. Let's go down here and we'll do print example of NaN, and then comma, not a number. Save. And let's see what we get. NaN, right there, not a number. Now let's see some operations with NaN, and note that any operation involving NaN typically results in NaN, indicating an invalid result. So invalid result. So we'll do pound operations with NaN. We'll do print NaN NaN added to a number, colon, and then do comma, not underscore a number plus 5. And on the next line, we'll do print NaN multiplied by a number, quote, comma, not a number, times 2. Save. Okay. And save. And let's see what we get. Let's do the play. And you can see NaN added to a number is NaN. And NaN multiplied by a number is also NaN. So let's do one operation here, another operation here. We will run a comparison. So checking if a value is NaN. And we'll do print, open parentheses, is NaN equal to NaN? Question mark. And then colon. And then comma, not a number. And we'll compare it to not a number. Okay, so checking if a value is NaN. And interestingly, comparing NaN with anything, even itself, is always false. So this is useful for checking if a value is not a number. And let's run it. And you get false right there. Let's do something else here. We are going to do import math. Normally we'd import at the top, but I'm just demonstrating something for you here. We're going to do print, open parentheses, using math.isNaN. So using math.isNaN to check NaN. All right. Do comma, and let's do math.isNaN, and we should see it right there pop up, open parentheses, and let's, in there, we'll do not a number, save. Okay, and let's run it. So true, you see that? So using the math library, we can actually check if a number is not a number. If a number is NaN. So you do math.isNaN and then put whatever the variable name is And if it is not a number, you will get true back. So this is very cool, and you'll use it at different times in simulation and in real robots for different use cases. So that's it for basic programs using Python. You've gotten some really good experience building programs to perform fundamental calculations. Thank you, and I will see you in the next tutorial. Keep building.